Okay, so let's look at question 4. So we can see the question quite simply says solve the equation 2x cubed minus 3x squared minus 12x plus 20 is equal to 0. Okay, so this is a cubic equation. That's the first thing that we should know. So we have a cubic equation or a cubic polynomial. And to solve a cubic, what we generally did in class was we started with some trial and error. And the trial and error, the goal of this was to find one of the roots of the equation. So we subbed in different values of x, hoping that one of them would be a solution of the equation, a root of the equation. Once we had one root, we could rewrite that as a factor and divide in to then find the other factors. So that's what we're going to do. So with our trial and error, the one we want to try, I suppose, is going to be x is equal to 2. If we do that, we can sub in for 2 all the way along our equation. We can work that one out. So 2 squared is obviously 4. We're going to get 16 minus 12 minus 24 plus 20, and that is going to be equal to 0. What that means for us, is that x is a root. X equals 2 is a root, which means then that x minus 2 is a factor. Remember that a factor of an equation will divide in evenly with no remainder. So that's what we're going to do. We're going to divide in by x minus 2. So we're taking our original equation 2x cubed minus 3x squared minus 12x plus 20. We're going to divide in. Okay, so this is where we have to remember our steps for our long division. So first of all, we divide the x into the first term. So 2x cubed divided by x gives me 2x squared. Then I'm going to multiply. So if we remember that it's divide, multiply, subtract, bring down. So then I'm going to multiply, so I get my 2x cubed minus 4x squared. Then I take my minus, and I get x squared here, and I bring down the minus 12x. Okay, next I'm going to multiply by x. Again, get x squared minus 2x. And again, just continuing with our usual steps for our long division. Minus 10. Okay, and we're happy to see that at the end here we end up with a remainder of 0. So that's obviously a good sign for us. What we need to do now is we need to take this new equation that we've ended up with and we need to solve it. So that obviously is a quadratic equation, so we'll take it over here to the side. Minus 10. Okay, following the steps that we did earlier as well with our quadratics, we should be able to solve our quadratic fairly quickly. This is where we'll get to, and then x is going to be equal to minus 5 over 2, and x is going to be equal to 2. Okay, the reason we have to continue on with that is that we're asked to solve the equation fully, and what that means is we need to find the 3 solutions. We already had one solution up here, which was that x is equal to 2. When we divided that in, we were left with a quadratic. Solving that quadratic gives us the other 2 solutions. Okay, then you would be as well then at the end to write down your 3 solutions just very clearly, so that it's very clear the answers that you've got. X is 2, x is 2, and x is equal to minus 5 over 2. So obviously we have there a cubic that has a repeated root at 2. Okay, continuing on then, the next question requires us to do something somewhat similar. So we're using a similar approach, but slightly differently. So we're given 2 of the roots, minus 2 and 3, of a cubic equation again, an x cubed plus 4x squared plus ax plus b, and we're asked to find the value of the constants a and b. So if we have a root, so if minus 2 is a root, then f of minus 2 is equal to 0. Okay, that's not anything new. That is what we did in the previous question. So that was how we found out that 2 was a root. We subbed in, we got that the answer was 0, we were happy that 2 was a root. We're going to use a similar thing here then. So we're saying if minus 2 is a root, then if I sub in minus 2, my answer should be 0. So we start off by subbing in minus 2. Anywhere that we see x, we're going to sub in minus 2, noting as well that we still have that a and b, but that is fine. Okay, so my next line, minus 8 plus 16. Watch out for those minuses when you're doing your squares and your cubes, just to make sure that we have it as accurate as possible. And we end up with a nice equation like this one, minus 2a plus b, and I've put the number onto the other side, and obviously that's for a particular reason, but we will hopefully see that when we come to that point. Next I'm going to do the same thing with my other root. So our other root was 3, so we're just going to do the same thing again. We're going to sub in 27 plus 36 plus 3a plus b, and 3a plus b is equal to minus 63. Okay, what we should see now with these two equations is that we have two equations with two unknowns, which means that we're going to have to do a simultaneous equation. Okay, simultaneous equation. So let's give that a go. Minus 2a plus b is equal to minus 8. 3a plus b is equal to minus 63. Oh, sorry. Let's just redo that line. Okay, so we're going to be solving a simultaneous equation. Okay, the easiest thing to deal with here is probably the b. So let's multiply the top equation by minus 1. We get 2a minus b is equal to 8. 3a plus b is equal to minus 63. We should be able to do a simultaneous equation fairly well ourselves. So minus 55 and a is equal to minus 11. Then we sub back in for that value of a. And again, this should be something that we're fairly confident with. We get that b is minus 30. Those are my two answers. So b is minus 30, a is minus 11. Okay, we should be fairly confident with the simultaneous equation, but getting to the simultaneous equation might be the hard part. So that first step was using what we had called the factor theorem that we came across in that second chapter of algebra. So the factor theorem says that if something is a root of the equation, then if I sub it into the equation, the answer should be 0. And that's essentially what we've used for that first bit. So since minus 2 is a root, it's the solution of the equation. When I sub it in, the answer I get is 0. And then I do the same with the 3. And by doing that, then only at that point did I recognize that I'm going to be doing simultaneous equations, because I have two unknowns that I don't know how to solve. So it's kind of a key thing here, I suppose, of not necessarily that you need to know exactly where you're going when you start the question, but you just need to make some sort of start at it that makes sense and see where it takes you then. So the clues, I suppose, in this question were the fact that there were two unknowns, a and b, and there were two numbers that we did know that we were going to be able to use. That was maybe the thing that would kind of clue us into, okay, maybe there's going to be some sort of simultaneous equation or something like that down the line. But I suppose the takeaway at the minute is that idea of subbing in the minus 2, working through it, and then moving to that simultaneous equation, and being able to do this again if we saw it in another question.